Here we will talk about the difference between even and odd functions and how to determine whether a function is even or odd. Even functions visually are symmetric about the y-axis, while odd functions visually are symmetric about the origin. It is harder to see something being symmetric about the origin, but I will show a few examples visually. If we have an even function, it might look something like this, where if you were to flip it over the y-axis, it would land on top of itself. So this is an example of a function that is symmetric about the y-axis, therefore it's even. A graph is symmetric about the origin when you could flip it over the x-axis and then the y-axis in either order, and it would land on top of itself. An example could be the function 1 over x, which looks something like this in quadrants 1 and 3. If you were to flip this over the x-axis and then the y-axis, each part of it, you would land still on top of itself. So that is an example of something being symmetric about the origin. And then algebraically, the way that we determine whether a function's even or odd is if when we plug in negative x, we either get the exact same function out, that means that it's even. But if we plug in negative x and get the exact opposite function out, then we know it's odd. If neither of these things work, then the function is neither even nor odd. Let's do a few examples. All right, let's take a look at this first example here. In order to determine algebraically whether a function is even, odd, or neither, you need to plug in negative x. So let's plug in negative x. So we want to find f of negative x to test and see. We want to see what we get out. If we get out the exact same function that we started with, f of x, then our function's even. But if we get out the exact opposite, negative f of x, then our function's odd. So let's plug in negative x. So we'll cube negative x and then we'll multiply it by 12. When you cube something that's negative, it comes out negative, so this is negative x cubed, and this would end up being minus 12x. Simplifying the first term, we'll get negative 13x cubed minus 12x. So it looks like what ended up happening is when we plugged in negative x, we got out the exact opposite of f of x. F of x had both terms being positive, so its opposite, negative f of x, had both terms being negative. So since when we plugged in negative x, we got the exact opposite function, all the terms were opposite, that means this function is an odd function. It's also to be noted that if you look at the exponents in every single term, they're both odd, 3 and 1. So that's another way you can determine that this function was odd because all of the terms had odd exponents. All right, let's try this next example. So we want to plug in negative x and see what happens. So we're going to be squaring a negative x. When we square a negative, it's the same as squaring the positive version of that number, right? So when we square a negative x, it's going to turn positive because we're squaring it. It's an even exponent. So it looks like what just happened was when we plugged in negative x, we simplified and got back to the original function. So here's what happened. When we plugged in negative x, we got back to our original function, f of x. When that's the case, and you get back to your original function, that means the function was even. Another way to know that this function was even is that there were two terms, and this term had an even exponent. So did this term. This is really 16x to the 0, right? This is a constant. So 0 is also an even number. So this is an even function. Okay, here's our last example. So we want to determine again whether this function's even, odd, or neither. When we plug in negative x, we'll see what happens. All right, raising something to an odd power, if it was negative, gives us a negative output. So This will end up being a negative number here. Multiplied by that negative 4, we'll change this to a positive 4, x to the 5th. Cubing a negative number gives us a negative output. Multiplying by that positive 2 will give us a negative 2, and then that number cubed. And then squaring a number will give us a positive output, or it will stay the same. All right, let's see. Did we end up with the exact same function? A negative, nope, we did not. We did not end up with the exact same function, so it's not even. Did we end up with the exact opposite function? Everything's opposite. Well, this term's opposite, but this term was the same. We didn't end up with f of x, nor did we end up with negative f of x in the end. So this is neither even nor odd.